yeah, what is scope? That's a great place to start. Scope, I would say, is just kind of it defines what variables you can access at a certain point in the code. So you can point to somewhere inside a function or in the global scope, and say, oh, okay, in this scope, I can access blah blah blah. Yeah, that might be a little floaty. So should we look at some code to make it a bit more concrete? All right, looking at this code that I made earlier, let's just first identify the different kinds of scope that are in it. So first up is the global scope. Ta-da! Yeah, the stuff that isn't inside a function. Then we've got 3 function scopes here. They also call function scope the local scope. And we got the 3rd scope here, which is a block scope. Nice. All right, so there's a fair amount going on, and let's have a look at the code, and we'll run through it and see what it all means. Okay, so at the start, we've got normal variable a is being assigned a value of 5. We carry on down, it console logs it. Yeah, it's 5. Not too surprising. The function bit crusher is called, it goes inside there, and now a plus 10. What do you get? 15. All right, so this is the first thing, I suppose, about scopes. So scopes kind of contain their own variables. So the function bit crusher might have some variables inside it. It doesn't in this case. So when you get a variable lookup, you know, the engine saying, hey, where's A? It's first going to look in the scope of bit crusher, but there's nothing there. And now this is what scopes and the scope chain are all about. The scopes are chained together, so it's looking for A, it looks inside the function scope, can't find it, it goes to the outer scope, and that outer is the same as, well, it is the execution context outer that if you saw the other video, we kind of quickly mentioned there. It doesn't matter if you haven't. The main thing is an execution context has a reference to the function's outer environment. We'll talk about that a bit more. But anyway, for now, it's just looking up A, it's saying not in the function, goes to the global scope, great, so it's 5 plus 10. Cool. Now the code goes to Zeit, and it's going to run that. Whoa, so we've got a variable declaration with the same name as the one in the global scope. Now, does that matter? Maybe. But it's not causing any errors, because as it just said, scope, like a function scope, has its own variables. So when we get to here and it says, hey, what's the variable of A? It looks in the scope of the function. Oh, okay, I found A. So that would be called shadowing as well, because you're kind of blocking this variable from being used, you're shadowing it. So yeah, this A equals 100 is the one that's used inside this function. Okay. And it's worth saying as well that the whole scope, the chaining thing of looking up variables obviously only works up. So if you're inside a function, it can't find the variable it's looking for, it looks up. But it wouldn't even make sense that in the global scope, you're trying to look up a variable and then it starts looking inside functions. No, it's a one-way thing up to the global scope. Okay, so that is, as expected, 110, because it's getting this 100 and adding 10 to it. Then this is a little bit interesting. So it calls this bit crusher function again. Okay, now what's the result from that? It is 15 again. So that may or may not surprise you. But either way, it's a very interesting point, and that is that the scope chain is static. It is it's kind of created from where the functions are typed. They say where they're lexically defined, which is a very posh term for just where they're typed. So, as you said, we look for A inside here. it looks up once in the scope chain. So it's saying, okay, I'm in here. What's my scope? It's the, what's my scope chain? What's my outer? It's outside where it was typed. So that's like kind of up one level. See, if it was dynamic, you would say that up one level, if you're thinking execution context, the call stack, up one level from Bitcrusher is Zeit, right? On the call stack, Bitcrusher's on the top, Zeit's underneath, and the global scope's underneath. So up one level, or on the call stack down one level, would be Zeit, but it's not. It's not. It's it's static. It's lexically defined. So it's 15. And that is interesting because there's other programming languages that are dynamic. So in those, what would A be? A's 100. You call Bitcrusher, it'd be 110 in here because it's using that kind of call stack parent rather than its lexically defined parent. Whew. All right, hopefully that made sense. It's easy to waffle on with these things. All right, so we've come back down here. Raspberry. So we're going to call that. Boop. And now this is the third type of scope, which again is a little bit interesting. So what have we got here? Inside Raspberry block scope, A is defined again as 0, and we're going to console log that. What's the result? It's 10, which again makes sense, right? 0 plus 10. That's not too surprising. Then when we carry on, console log here, this ends up being the same as Bitcrusher basically. It's looking up A in the global scope. So what's the interesting part is that because of let, and that is why block scope is only introduced in ES6, because it's let and const, they respect these parentheses here, the if blocks or for or something like that. Before that, if I change this to a var, it would actually, do you know what? Let's go wild. Let's just do it. Okay, this actual text hasn't changed, but the code has changed. This is just HTML. And now you see block scope, function scope, they're both 10 because this is a var. Do you know what? I'm going to change it because it is a little bit confusing now. Sorry, I think my videos have gotten a little better, but I'm still no pro, Cool. Yeah. So if this is a var, then this isn't a scope. This is ignored, and this is a function scope. This is all one function scope together. If that's a let, then it respects this block scope here. All right, so hopefully that all made sense, and there was something in there for you that was interesting. But global, function, block scopes, and a little bit about the scope chain and how they work. Moving on then. The scope chain and the execution context, they sound really similar, right? Because there's a global one, a function local one. And I think there is some confusion, thing like, is it actually the same thing? They are separate things. They do interact. So yeah, it's a little confusing. So here we've got a little compare and contrast bit. So the scope chain, I mentioned that it's lexically scoped, lexically defined, and static. And as I said, that means that wherever the function is typed, that's its position in the scope chain. So if you've got a function typed within another function, then the scope of the inner function, there's that one, and then the next one up on its scope chain is the surrounding function, and then the next one up on the scope chain, the global or even another function. So the thing is, you can look at it, you can look at the code and be like, okay, these are all the scopes. This is how the scope chain works. You know it, like before you even compile it. You can see the scope chain itself. Execution context, as I put on here, related to the call stack dynamic, that's different because you could never say what the call stack would be in a when you run a script or something, because you got event handlers. Maybe you got like an if statement. If you know, this happens, then run this function. If this happens, run this function. If the user clicks on something, run this function. So you never know what the call stack would look like. That's why it's dynamic. You know, you can as the program runs, the execution contexts are formed and executed, created and executed. So that's the difference there. You know the scope chain at compile time. The execution context, you have to wait until runtime to see what's going on with those. So the execution context, also the second point on there, it uses the outer reference. So when we were talking about execution context, it's got this little outer thing that helps it know what its kind of parent is. Let's say lexical parent, but what it is the scope chain. It's what its scope parent is. So it does. The execution context uses the scope chain, but then if we look at the second point on scope chain, it says persists after execution context popped off the stack. So what that means is that, as you know, execution context created, executed. When the function's gone, that all the information related with the execution context, contained by the execution context, is then gone. But the scope chain is still known. It persists. It would still have information about variables in certain circumstances. And what we're going to talk about next is closures, because this functionality of the scope chain, this is what makes closures work, which is nice. So let's have a look at that. Yeah. So here we go for the best bit. Looking at a closure. Now there's plenty of complicated examples you can find around the internet to really maybe get to know closures really, really well, but I'm going to go for a simple and clear example. And if you want to go closure mad afterwards, you know, it's your life. So what we've got here, we've got a equals 5 again, a bit boring, not very inventive. We've got this const king, and it's calling the function candles. So we're going to go into candles. There is a new variable, color, magenta, and here's the exciting bit. It returns a function, mountain. So by the end of this code, I mean, nothing's really going to have happened in terms of console output, because we're going to execute this and we're going to store whatever's returned from the function candles, which is this. So we're going to get a function back. King is going to be a function that we can execute. And yeah, let's have a look. Let's do so. Wow. So, as you might have guessed, the interesting thing here is that it still has access to this variable, color. And that is interesting because, well, let's look at the call stack and rerun this code. Call stack, not paused. I haven't run it, have I? What a silly man. Here we go. There you go. There's the call stack. The call stack is inside mountain, the function. Candles is nowhere to be seen, which makes sense because the execution context, it was created, it was executed, it's gone. The information in that execution context has gone, but mountain is still got a reference to the color variable, and that is because it is held in the scope chain, which, as we said, persists. So that information is still there. So that's why closures work. That's why closures work, because the execution contexts are dynamic and the scope chain is static. So together you can make closures, which is fantastic. And obviously, I mean, especially back before private variables in my old days, closures are a really good way to make things private, because you can't, I can't mess with this variable anymore. It's private to, mountain's the only thing that can, this mountain function is the only thing that can access it. So it's kind of sealed away. It's closured off, if you will. So yeah, as I say, like you can look at more complicated examples, but that's it. So if someone asks you in an interview, say, hey, tell me about closures. Like, oh wow, interesting, closures, yeah. Well, I mean, that's due to the execution context being created dynamically, and the lexical scoping of the scope chain being static, and that makes it possible to be able to make a closure, but obviously do it more smoothly, not kind of like a stuttery nerd like me. But yeah, you get the idea. So it's cool, right? Because you only learned a few things, and then you can like really explain why closures exist, why you can make one in JavaScript. But that's it. That's it from me today. So we covered scopes, the scope chain, and closures. It almost felt too quick. So I hope I covered all the topics adequately. And if I said anything wrong, feel free to blast me in the comments. All right. Thank you very much, everyone.